Hello people, today we'll be solving LeetCode DailyQuestion 787, that is cheapest flights within K stops, and in this we'll be given n cities connected by some number of flights, and we'll be given an array of flights where flights I will represent as from source to destination, the cost or let's say price, and we have to indicate that there, yeah, I wanted to do that, and we need to return we'll also be given three integers, source, destination, and k, and we have to return the cheapest time from source to destination with at most k stops. And if there is no such route, we have to return -1. For example, in this case, we are given this is like the proper graph, and my source is 0 and destination is 3. Like so, like from source 0 to I have to reach 3. So there are multiple possible paths with let's say 0, 1, 2, and then 3 is one of the possible, or 0, 1, 3 is possible. And if you see that 0, 1, 2 will cost me less, that is 100 plus 100 plus 200, that sums to 400. But the constraint is that I am also given the maximum number of stops that I can take, that is 1. So if I am given the maximum number of stops that I can take in 1, so I have to choose this path, because in this I am having only one stop, that is 1. So I'll go from 100 and then 600, so that will cost me up to 700. Okay. And if there are, let's say there would have been some other path also, for example, if this would have been the graph like from 0 to 2, then I can reach 3, then I have to return this answer, because 100 plus 200, that will sum up to 300, which is clearly less than 700. Okay. So for this, what we'll be getting some of the extra classes, or let's say some extra data structures. So let's first data structure, let's call it tuple, and then this we'll be storing the end stops, the number of stops in my node, and the cost that I've and incurred till the current situation. And let's initialize these variable stops int node and int cost, and I'll just this dot stops equal to stops, and let's just yeah, oh sorry, not here. I'll have to delete these two. This dot node is equal to node, and this dot cost is equal to my cost. And similarly, for creating the adjacency list, we'll be needing a pair. So let's initialize this pair also. So this will be having destination and my cost to reach that destination cost. So let's initialize it and write its constructor, that is int destination and int cost. Okay, so this dot destination is equal to my destination, and this dot cost will be my current cost. Okay, so now firstly what we'll do, let's have the graph, that is list of pair, uh, and let's call it adjacency list, that is equal to new array list. Yeah, a new array list. And then what we'll be doing, let's add a empty pair, that is for int I equal to 0 or less than n, sorry, not an empty pair. Let's add a array list, empty array list dot add new array list. Okay, and let's have a variable m that will be of flights dot length size. And now here we'll be updating our graph, that is for int I equal to 0, I less than m, or let's, why are we even doing this, let's just do flight and flights, a good coding practice, I must say. So what I'll be doing is intensity list dot get flight 0, and here we are adding a new pair of flight 1, and the cost that is present on the second index, flight 2. Okay, and let's just now create a queue of my tuple queue, that is equal to new linked list. And in this linked list, what I'll be doing is I'll be adding my source, that is q dot add new tuple, source, so not it's of the form stops. Yeah, so currently my stops are 0 and my source is source, and my cost to reach that source is also 0, and also have a distance array because we'll be using kinda Dijkstras for this. So new int of size n because it stops, and we'll be setting distance to reach the source is 0. Okay, no, let's first set the distance to the maximum value. That's for it I equal to 0, I just then n, then I plus plus, and my distance I will be equal to the maximum value, that is integer dot max underscore value, and then I'll be setting my distance of source to 0. Okay, and now let's just simply run the while loop, that while not my queue is empty, what I'll be doing is I'll be popping off the topmost element from the queue, that is tuple, and it's called that will be equal to q dot poll. And now let's extract these, the values, that is int stops will be equal to dot stops, and int node will be equal to tube dot node, and my cost will be equal to tube dot cost. And here I'll be checking that if my stops are greater than k, that is we should, there's no fun in traveling this, so we'll just continue. And then what I'll be checking is that for pair, it's called pair in adjacency list dot get node. What I'll be checking is I'll be extracting the values firstly, that is adjacency node will be equal to pair dot node, or I guess it's pair dot test or pair dot, yeah, sorry, destination, and the edge weight or the cost, let's say I've declared the cost above, so I'll be using edge weight, that is equal to pair dot cost. Okay, and here I'll be checking that if my current cost plus the edge weight is less than the distance, is less than the cost to reach that particular node, that is my adjacent node, and my stops are less than or equal to k, in that case only I'll be updating it, that is my distance of adjacent node will be equal to the cost plus edge weight. And then I'll just add this to my queue, that queue dot add new tuple with the stops, and my stops will be increasing by 1, and my adjacent node, and my cost plus edge weight. Okay, and at the end what I have to do, I have to just return that if my distance of my destination, that is I guess dst, let me just check, yeah, it's dst, is if it is equal to integer dot maximum value, so in that case I have to return -1, otherwise I have to return the distance. Okay, so now let's just run it. Okay, so it states oh, yeah, now let's run it, and it gets accepted. Now let's submit it, and it works perfectly fine. Okay, so this was it for today. Thank you for watching.